Hey guys, welcome back. So I'd like you guys to go through this first part. It's a little warm-up activity, kind of get you like in the frame of mind for what we're going to be doing. It's not really that much different than what we've done before. So I'll let you do that. And I want you to do this too, so you guys can work through this one. Come see me if you need a hand, but it's pretty straightforward. It's more like you're going to do skills that you should know how to do and then just kind of arrive at a few conclusions. So do that. But then I just want to kind of lead you through this part. So before we had this formula, right? The one right there. So K is equal to the model divided by the original. And K, remember, just meant the scale factor. So that was the lesson before this, right? And when we were talking about that, we were talking about like, you know, the length of the model. And the bottom would be the length of the original. So that was in like one dimension, right? You got like the length of a line and then the length of that line. So the model here would be, you know, one, like the length of one, and this would be a length of two. So in that case, K would be equal to 1 over 2. But those were lengths. The only thing that's really changing here now is we're talking about area. So if we drew something like a box, and just kind of ignore this question for a second, I just kind of want to get your head in the right place. So now if we're going to be doing something with a box, right? So if this was like a box with length 1 and length 1, we're talking about the area now, right? So 1 times 1 for the area. This would have a area of, let's say, 1 meters squared. But if we drew a box that was twice as big, it's going to be 2 by 2. So the center would be 4 meters squared. So that's where we find this equation from. It's always going to be K, but now squared. K squared is equal to the area of the model divided by the area of the original. So it's always, so in this case, you would write this out as K squared is equal to area of the model was 1, area of the thing you're making bigger, let's say in this case, was 4. So it would start out by being K squared is equal to 1 over 4. So yeah, that's kind of the idea there. But behind kind of what I've done here, there's a question that says if an airplane model is constructed so it is 1/5 the size of the original, we say that the scale factor is 1 over 5, right? And you've done that in the last one. Often the scale factor is abbreviated K. The equation for linear measurement, like we said, was this. If we asked to find out how much paint it would take to cover the airplane, painting deals with surface area. The above equation becomes, so that's now this equation, right? So if we wanted to solve this, the typical question might say it takes 40 meters squared of paint to cover a model 1/5 the size of the real one. All we have to do is use this formula and just kind of plug in what we know. So we start out with K squared, and then the area of the model, well, it told us that in the question, right? It takes 40 meters squared of paint to cover the model, and then over the area of the original. So we're looking for the area of the original. Any idea how we would solve for X in this case? If not, all you got to do is actually just, I'll walk you through how to solve this. So this side is squared, right? So you go 1 squared and 5 squared. Everything inside those brackets gets squared, so it ended up being 1 over 5 squared is 25. Hopefully you see what I did there, right? You squared the top and squared the bottom. Is equal to 40 over X. And now we could rearrange this algebraically, or you could use your fish thing, right? Or solving by cross multiplying. So 40 times 25 divided by 1 gives you X. And if you do that, you get 1,000. So X is equal to 1,000 meters squared. Okay, so that's kind of a typical question. So I'm going to let you guys go ahead and do this one too, this example. Yeah, I think you should be able to follow the directions and just do that one. This one, I'll walk you through this first one, and then I'm going to leave you the last one. So this one says, Jasmine is making a kite from a 2 to 25 scale diagram. So that's K, right? I know that right off the bat when it gives you like a scale, that's K is our formula. The area of the scale diagram is that. How much fabric will she need for her kite? So that's the actual one. So they give us the model. So we just need the area of the other one. So if we give our formula, okay, so I wrote my formula out. In this case, we'll say area of the model, or the area of the scale diagram, same thing, over the area of the kite. So that's our formula, right? So all we need to do is just kind of fill in what we know. Instead of writing it as 2 dot dot 25, I'm going to write that as 2 over 25 squared is equal to, and now the area of the model, the top one, I know that's 20. So I'm going to put in 20 over, now I don't know the bottom. This becomes, top and bottom are both squared, right? So this becomes 4 over 625, because that's 25 squared, is equal to 20 over x. And when you solve for x by either cross multiplying or by rearranging to solve for x, you get x is equal to 3,125 centimeters squared. All right. So I'm going to let you guys go ahead and do this one. I'll give you a couple hints here. It gives you a laptop with a monitor dimensions this and a new image. So you're going to have a laptop with these dimensions, 9 by 12. So, like 9 by 12. What you're going to want to do first is figure out what is the area of that laptop. And then that laptop is being made larger, right? The image on the laptop. So instead of 9 by 12, it's going to be something else by something else, but we do know the area of that. That's going to be that number inside here, right? That's the area of our larger image that's being displayed on the monitor. What we have to do again, though, is start out with this formula. And we're looking for K this time. So I'm going to let you guys go ahead and do that. And then I want to make sure you guys just go and do the questions on my website as well. So when you're done this, do the questions on my website, and that's it. So I'll see you guys in class.